Hi, I'm Frank Hermes, and this is Rocket Electronics. And this is the series of videos that will hopefully orient you to the features and use of the new RockeTiltometer. Hi, this is another in the series of continuing videos on the functions, features of the new RockeTiltometer. And in this video we'd like to describe the connections to terminal strip T1, which is here at the top of the board. One of the advantages of the RockeTiltometer and nice features is the ability to nest a Raven flight computer on the RockeTiltometer, and we've done this primarily to take advantage of several of the programmable attributes of a rocket's flight that are available and configurable on the Raven, and then use some combination of those, even if it's just a simple timer so many seconds after booster burnout, or a little bit more complicated that's looking at the changes in the atmospheric pressure, changes in time, changes in altitude, etc., that are configurable in the Raven. And we can use that as the external trigger source for the RockeTiltometer. We've talked about external trigger sources in particular in another session that we did on the video, talking about terminal strip T2, where we can bring in either an active high or an active low external trigger signal to call for ignition from the RockeTiltometer. And as you know by now, the purpose of the RockeTiltometer is to accept a call for ignition, and then depending upon the attitude of the rocket to the vertical or z-axis, if the rocket's flight is within the critical angle that you have set, then when that ignition is called for, then ignition will be granted, and the ignition circuit on the RockeTiltometer will then go ahead and fire the igniters that are on your staged or air-started motors. If the angle has been exceeded when ignition is called for, then ignition will be inhibited, or probably a better term in this case would be aborted. So you can use these external trigger signals out here, or you can nest a Raven flight computer, which we provided a header up here that accepts the terminal strip on the Raven, and a mounting hole here at the back of the board so that it mounts securely in there. And then we can use Pyro channel 4 and everything that featherweight altimeters allows you to use as criteria for a flight event are available to you there. While the Raven is nested in the RockeTiltometer, the system battery source that is powering the RockeTiltometer also then powers the Raven. So the Pyro channel number 4 is used for an external signal to the call ignition on the RockeTiltometer. Well, while the Raven is nested in the RockeTiltometer, we also wanted to allow you access to the other 3 Pyro channels that are included on the Raven, and that way you can use the Raven for your normal dual deployment events, for example, or any other things that you would use the Raven Pyro channels for. So while the Raven is nested in the RockeTiltometer, the system power source is used also to run the Raven. And as long as the use of the other 3 Pyro channels is lightweight as far as the amperage is going to be used, for example, if you're just popping E-matches, then that system source would be fine. And in that case, the terminal strip T1, just below that a little bit, is this little jumper panel, and in that case where the Pyro channel for the Raven, the other 3 Pyro channels are going to use the RockeTiltometer power source, then you would close the jumper on the 2 terminals to the left, and then that means that the power that will go out to the Pyro channels, that means that the power that will be used for the other 3 pyro channels on the Raven will be the same as the system source. In the event that you're going to use higher ampacity devices on those other 3 pyro channels, then we would bring in another external power source, another LiPo or whatever that you wanted to do. And if you were going to do that, you would connect that power source to terminals 9 and 10 on T1, and then you would, if that was going to be the case, then you would connect the other external power source to terminals 9 and 10 on T1, and you would move the jumper to the 2 pins that are to the right on that little jumper panel. And in that case, now any of the events that are going to occur on pyro channels 1 through 3 would be pulling off of this external source. On terminal strip T1 pins 7 and 8, there is provision for an on-off switch, and regardless of whether or not you're using the system source to power the pyro channels, or you are using an external source to power the pyro channels on the Raven, you would use the on-off switch. And the way the circuitry is on the Raven is that the continuity check is continually pulling power off of any source that's applied to them, so you can't just leave a battery connected, which is probably not a safety related best practice anyway, but you can then use an external on-off switch to control application of the pyro battery source for the other Raven pyro channels 1 through 3. And again, that would be regardless of whether or not you use the system source or another external source on the board. So that way you've got access to the other 3 pyro channels on the Raven, leaving the 4th Raven channel to act as the external trigger for the RockeTiltometer. And all of this is covered in our manual on the RockeTiltometer, and that's found at the www.rocketelectronics.com website. And information on the Raven is found at the featherweightaltimeters.com website. That takes care of T1.